Today, we'll be learning in Protastructure how to manually design your beams. And why is this important? It's really important because manually designing your beam to make your design to be practicable based on what is obtainable in your area, because sometimes it might not just be you interpreting this design. It might be, local artisans that you have to work with. It might also be some other engineers. And it's very, very important that whatever you're designing is as relatable as possible so that what you have designed will be what will be transferred into the reality. Now we have this design right here, and as you can see, I've actually activated my design status, and I have the design status indicating that everything here is okay, so which means my beams are also okay. This is after I've done the automatic design. Protastructure software has done the design for me, and it has labeled every of my structural members okay, so you can go to review. This is your design status. Click on this to see your design status, and everything is okay. But because it's okay here doesn't mean everything is really okay. So what I'll first go and do here is to check for my columns. You can see all columns are actually okay right here. So what I want to do is I want to go back to my analysis. Then in video analysis, I'll go to post analysis, and I'll check column wall design to see all my designs and make sure that what I have here with my steel bars is very, very practicable, because sometimes it can come with designs that are not really practicable. Like you can be seeing something like, let's say 6x16, when you can actually have an economical 4x16 and come with 8x16, even when in reality you can have just 6x16 sufficient for your reinforcement design. And this is where you juxtapose what you have here with what your design status also says, because when you manually design, it will let you know whether what you have designed is okay or not. The beam is actually the focus of this. Everything is okay with our column, so we don't really need to work on our column. 5x16 is okay. 175 spacing for the links, which is y10, and you have the utilization ratios here. So now let's close this and go to our beam reinforcement design. Now when you go to this interactive design for the first one, you see exactly what I'm trying to say here. Because I've corrected this, you realize that what you have here is that we have for the top bar you have 2y16, and you have this support bar that is supporting the top bar 1y16, and you have the bottom bar to be 3y16, and this top bar actually overlaps. This also doesn't overlap. So let me go here and go and look for the one that is not okay so that we can work on it. Like this one now is really, really very complicated. Now for this one, you see that you have 2y50 here, which doesn't seem right. Y50 is not supposed to be part of what we designed, but for some reasons it's here, which is terrible. And you can see that while the design is okay, you realize that this is actually going to be a disaster, an economic disaster to include in your design. And that's why it's always advisable for you to manually design your beams.